to this lesson, and then we're going to move on to the next one. So what do you notice? What do you wonder? This first one says 7 times 9 equals 63. 7 plus 9 equals 16. 7 minus 9 is -2. 7 divided by 9 gives me 0.77. Are there any patterns or anything? Go ahead. Okay, so we got operations of 7 and 9. Okay. Okay. So smaller as we go on with our operations. Okay. I don't know why there's 3 L's, but we'll go with it. Cool. No. All right. So today we're going to investigate closure for polynomials. Determine which are true statements and then justify your reasoning. Okay, so if you multiply 2 integers, you'll always get an integer. Is that a true statement? If you take 2 integers, you'll always, when you multiply them, you'll always get an integer. All right, so let's have this conversation first. What is an integer? So what's the definition of an integer? A whole number that is what? Not a fraction. Okay. So if I take any numbers, any 2 numbers, let's say like 11 and 7, and I multiply them together, that's going to give me a whole number, right? Like it's always going to give me an integer. So that's true. Okay. If you add 2 integers, you'll always get an integer. Is that a true statement? Yeah. Okay. If you subtract 1 integer from another, you'll always get an integer. Is that a true statement? Yeah. If you add 2 even numbers, you'll always get an even number. Is that a true statement? If you add 2 even numbers, you'll always get an even number. Okay, people who telling me no, give me an example. 4 plus 8, what does that give me? Is 12 even? Yeah. Is there another example you can think of? 8 plus 8? Okay. That one works, right? If you subtract an even number from another even number, you'll always get an even number. If it works for addition, it must work for subtraction too. Okay. If you add 2 odd numbers, you'll always get an odd number. Okay, so let's think about this. Let's try 3 plus 3. Those are 2 odd numbers. 3 plus 3 gives me, okay, so that one doesn't work. Right? If you subtract an odd number from another odd number, you'll always get an odd number. Okay, so if we take an odd number and you subtract an odd number, 5 minus 3 gives me, and that's not an odd number, so that doesn't work. If you multiply 2 even numbers, you'll always get an even number. Yeah? Okay. Before you check it. 8 times 8 gives us 64. Is there any other example that you can think of that wouldn't work? 10 times 2, 10 times 40, or I'm sorry, times 4. All right, I'm thinking that one works, right? All right, if you multiply 2 odd numbers, you'll always get an odd number. Okay, why? Give me examples. 7 times 3 gives me 21. 3 times 3 gives me 9. What about it's always going to be an odd number, right? Okay. Ooh, but is 8 an odd number? No. Okay. All right. So go ahead and take a moment. Which of the following are examples of a polynomial? Drag the oval onto the circle, or on your paper, you can just actually circle it. Take a moment. I want you to think through which one of these is a polynomial. First, somebody define polynomial for me. Huh? Not a real number. If I could say x plus 2, and I tell you that that's a binomial, and if I say x is a monomial, and if I say x squared plus x plus 1 is a trinomial, go ahead, say it. Somebody said it. More than one term. Polynomial is more than one term, right? All right, take a second. See which ones are polynomials. Okay, so which of the following are polynomials? So I'm going to circle the ones that are polynomials. You tell me if there's any that you disagree with. I think that's it. Okay, so why did I circle those? More than one term, right? Okay, good. The bottom?
The side? No, yeah.
Yeah.
Because I see the one on what?
Just exponent. Oh, makes sense. Makes sense. All right, so let's investigate these. All right, so today we're going to work on finding the answer to these two questions. If you add or subtract two polynomials, will you always get a polynomial? If you multiply two polynomials, will you always get a polynomial? I don't think you have this one in your packet. Okay, we're not going to spend a whole lot of time. Okay, so adding polynomials. What you're going to do is on the following slides, you're going to use the two cards to either add or subtract or multiply. Pick any two polynomials of your choosing in the chart and apply the operation described at the top of the slide. Record your answers in the text box below the pair of cards. We're only going to do one of these, but what you're going to do is you're taking this number and this number, and you're either multiplying them, adding, or subtracting. You get to decide. Same thing with trial 2. Okay. I want you to take a moment. You're trying to answer these questions. If you add and subtract two polynomials, will you get a polynomial? And if you multiply two polynomials, will you get a polynomial? We're trying to answer that question. So again, you're taking these two things, you're adding and subtracting or multiplying. And then you're going to do the same with this. Take a moment, try both of those. Okay, so if I have 14.3, are you listening? Plus negative 3x cubed. Well, I mean, that's in simplified form, right? Is that a polynomial? Okay, so we took two monomials and added them together, and we got a polynomial. Okay. Over here, if we take x plus 5 plus x squared minus 9, I can simplify this by combining my like terms. And I'm going to get x squared plus x minus 4. Is that a polynomial? Is that a polynomial? X squared plus x minus 4. Yeah. Okay, so we took two binomials or polynomials, added them together, and we got polynomials. Okay? So right now on your paper, I would write, adding monomials, you get polynomial. Adding polynomials, you get a polynomial. Take a second. On here, on your paper, you're going to say, adding monomials, that means one term, you're going to get a polynomial. If you add polynomials, you get a polynomial. These are things that you kind of already know, but you just don't have a name to like call them. Okay. We're going to do the same thing on the next one. Yeah, I don't like this part at all. I'm going to skip this. When you add two polynomials, the sum is blank a polynomial. What's going to go in that box? Always a polynomial? Okay. When subtracting two polynomials, the difference is blank a polynomial. Is it always a polynomial? Well, let's think about it. What if I had x squared plus x and I'm subtracting x squared plus x? Does that give me a polynomial? No, it gives me 0, right? So it's going to be sometimes a polynomial. When multiplying two polynomials, is it always going to be a polynomial? Yes, it'll always be a polynomial. Okay. Questions on this? This is always like one question on your final exam that they ask. They ask it really weird. All right, so here's a quick check. On your paper, there are 5 problems. I think this is blown up on the next page. Yeah. Okay, so go ahead and take a moment. Yeah, it looks like what's going to be on the board. Take a minute. You're going to tell me true or false. Okay, and then you're going to tell me why. Okay, you are going to turn this part in. Okay, so I need you to complete it. I'm going to put about 15 minutes on the timer, and then you're going to bring me your packet. Okay, so take a moment. You're working on these. You're telling me true or false, and then you're telling me why. Please don't just put true or false. So if I have this, I've got 3x plus 2 and then 4x plus 6. I'm going to add 3x plus 4x, which is going to give me 7x. 2 plus 6 is going to give me 8. Is that the same thing? No. It's going to be false. Okay. On the next one, we're subtracting. Remember, we're going to distribute negative. We're going to distribute this negative. So we're going to write this out again. So then we're going to combine our like terms. That'll give us 5x squared minus 5x plus 5. And again, not the same thing as what they got over there, so it's going to be false. Okay. We're going to multiply this one out. And we're going to distribute over here as well. When we combine our like terms, we're going to get 2x squared minus 15x minus 27. So that one's true. When we multiply this next one, remember, we're going to distribute both things. So this is going to give me 4x cubed minus 20x plus 12x. When we distribute the other thing, we're going to get plus 8x squared minus 40x plus 24. When we combine our like terms, we're going to get negative 4. I'm sorry, that's not a negative. So when we combine our like terms, we're going to get 4x cubed plus 8x squared. Oh, this one should be that one. I need y'all to stop talking. When we combine our like terms, we're going to get negative 12x squared. 12x minus 40x is going to give us 28x, and that's going to be negative, plus 24. Okay. Is that the same thing as what they got? No. So that one's going to be false. Okay. When we multiply this last one out, I'm going to do this up at the top. That way you can see it. We've got 2x plus 7. And when we multiply that, that's going to give us 4x squared plus 14x plus 14x plus, which one? On there. No, this is the last one. Yes. I got you. Is you're going to go to this document. I'm sorry, not this document. On here, if you missed numbers 3 and 4, I need y'all to listen. Oh, wait. If you missed 3 and 4, you're going to do this Desmos activity. So you're going to do the multiply binomials Desmos. If you got 3, but you missed 4, then you're going to do this multiplying binomials by trinomials Desmos. If you miss number 5, you're going to do the squaring binomials. If you got them all right, you're going to do the polynomial operation application through Desmos. Okay? If you miss 1 or 2, you're going to come sit with me so that we can make sure that you're ready for the next CFA test, etc. Okay, so looking at your paper, be honest with yourself.